Yo, what's up, Sci-Fam? It's Nickel, and today we're going to look at things that control the climate. There's really 5 different factors that we're going to consider looking at that are things that can cause regional climates to be impacted. Now, we've already looked and learned about property number 1 and 2. We're going to expand upon these and add 3, 4, and 5 onto there. But we're going to do this in a 2-part series. So our first video here will be part 1, and then we'll turn the page and do the 4th and 5th control in part 2. So be on the lookout for that. So here we go. We're going to be learning about climate controls. So to begin with here, the following factors, these 5 factors, are what control climate. And really we're looking at regional climate, so like a local or smaller area on the earth. Instead of looking at the entire earth, we're going to be able to zoom into our local communities and regions. So the following factors control, and maybe we should even say there, regional climate. And it's important to know that climate controls ecology. So if you've ever heard of someone wanting to be eco-friendly, it's because eco means home or earth. So it's really the study of the earth. So it's like climate controls ecology. It controls what can grow on the earth, like plants and animals and other things that can grow or exist on the earth. Climate controls the ecology, what is going to grow. So these next factors are what control our climate, and climate controls ecology. So each of these things do also control ecology in a way. So the first thing is the latitude. So latitude are these horizontal, it's like jumping from one spot to a more northerly or southerly spot on our Earth. So lines of latitude actually go north and south. And as you move further along that line, either north or south, you're changing your latitude. So we've learned that a more direct sun angle ends up having warmer temperatures, and a less direct sun angle ends up having cooler temperatures. And so as we've seen, let me get a new color here to really emphasize this, that we have solar energy coming from the sun. And let's say that we have this beam of light. Let's say that we're just looking at this one column of light, so we can look at how it's going to hit the earth. Now if we zoom in here, when it hits the earth, it's going to hit it at an angle which is going to cause this amount of sunlight to be spread out over a large area of the earth. Since we have this amount of sunlight here hitting the earth, if we take this same amount of sunlight, I'll even copy it from here, and if that area of sunlight is hitting down here on the earth, it's what we call a more direct angle. And it's a more direct angle because it hits more at a 90 degree. There's less of a curve when it hits the earth at this angle. So what that means then is that it's going to cover a smaller area. So we have the same amount of energy in a smaller area. So we end up seeing warmer temperatures in some regions, warmer temperatures and cooler temperatures because it's spread out over more area. Okay, that's latitude. So as you increase latitude from the equator, it gets cooler. As you get to the equator, it's warmer because it's more direct of sunlight. And as you go south, it gets cooler because the sun angle also becomes less and less direct. The second type of climate control that we've already discussed and gone in depth looking at is the atmospheric circulation or airflow. So if you're near areas of rising air in terms of the pockets of air that are large cells over our Earth, if you're near the rising air, that means that you're going to get more precipitation and more vegetation because there's more precipitation. And if you're near the sinking air or the falling air, I'm going to keep with sinking, near the sinking air, that means you're going to have less precipitation because the air is drier, and so you're going to end up having less vegetation because plants need water in order to grow. So if you remember and can recall, if we look at our Earth near the equator where the sun is heating the air rises, and in these regions we end up with a lot of cloud cover. The air cools and descends, At the poles, air cools and descends, which drives this northern polar cell. And then in the middle here, we have this feral cell, which has air descending in this region and rising in this region. The same thing is true here as we look towards the southern hemisphere. Air sinks towards the pole, it moves towards the equator once it sinks and it warms up, and we end up having descending air, rising air, and we end up with these cells, which we've already talked about, these Hadley cells, the feral cells, and the polar cells. So you can take a look at our airflow, planetary airflow science notebook page if you need a review of that climate factor. The third climate factor is a new one for us. This one, we're going to talk about elevation. So those of us here in Colorado, we know that elevation definitely impacts the air, the climate. What can happen in terms of our weather? So elevation, when we're thinking about elevation, the higher our elevation is, the further we are from sea level up above the earth, we end up having cooler temperatures. It gets colder the higher and higher you go up a mountain. Temperature is going to typically decrease by 3 degrees to 5 degrees Fahrenheit. Make sure you include the units. The units here is Fahrenheit. We're measuring temperature in Fahrenheit. So temperature decreases by 3 to 5 degrees Fahrenheit for every 1,000 feet of elevation gain. So let's say that we have this mountain. It's right here next to the ocean, and that means that its base is at 0 feet. Every line here, let's say, is 1,000 feet of elevation gain. So we go from 1,000 feet to 2,000 feet, and go ahead and draw yourself a mountain and label your mountain with the elevation. And we'll have a maximum here of 5,000 feet elevation. Now, let's say that you're down here at the base and it's a beautiful day. Let's say that it's a 80-degree day, 80 degrees Fahrenheit. Now let's take the maximum here of 5 degrees. It will also make the math a little bit more simplistic for us, but it'll also give us an idea of how much temperature can really change. So as you went up this mountain, let's say you're driving on the road up Trail Ridge Road in Rocky Mountain National Park, and you're going from one place where it's 80 degrees up 5,000 feet. Let's see what the temperature would be if you're currently at 80 degrees Fahrenheit and you're about to climb or drive up to 5,000 feet. So in the first 1,000 feet, we'd lose 5 degrees, so it'd be 75. We'd lose just 5 more degrees in the next 1,000 feet, so it would be 70 degrees Fahrenheit. We'd lose 5 more degrees for 65 degrees Fahrenheit. We'd lose 5 more degrees at 4,000 feet. It'd be 60 degrees Fahrenheit. And if we got all the way up to 5,000 feet above where we started, it would only be 55 degrees Fahrenheit on the same day that it's 80 at the ground. Now, the way that we can actually explain this in a quick manner is that if you think about the atmosphere is a bunch of air particles. And as you get closer to the ground, that means you have more air particles above you, which is basically more and more insulation. As we talked about the fact that we have greenhouse gases in our atmosphere, the more of the greenhouse gases you have above you, the more insulation you have from space, which is cold. So it's kind of like you have more blankets on you the further down underneath you go. And as you know, if you've ever laid in bed in a cold house, the more blankets you add, the warmer you get because they trap more heat. As you rise up through your elevation, you have less above your head, so therefore it gets cooler. All right, that is going to be the end of part 1, and we will begin part 2 here at number 4. I'll see you on the next video.